Yeah, welcome back. This is Earl Samm. Today we're going to be solving a problem involving change of subject. So we have this GP formula, sum of n terms of a GP. We want to make n the subject of this formula. If you're excited to solve with me, let's go. Okay, so what we have is S equal to A 1 minus R raised to power n all over 1 minus R. So first we can cross multiply. So we'll have A into 1 minus R raised to power n multiplied by 1, that's itself, equal to S into 1 minus R. That's S multiplied by 1 minus R. Okay, so we can expand with this A. So we have A multiplied by 1, that's A, minus A multiplied by R raised to power n. We have AR raised to power n equal to, can also expand this, S multiplied by 1 is S multiplied by R is SR. Now, because we're trying to make n the subject, let's isolate this term. Okay, so here we have A. Bringing this S down this way, it gives us minus S, and this minus SR becomes positive SR equal to, I'm moving this negative minus ARN to the other side, becomes positive AR raised to power n. Okay, so let me rearrange this to make it look familiar. So AR to the power n equal to all of these, right? Which is A minus S plus SR. Now I can divide both sides by A. So I have R raised to the power n equal to A minus S plus SR all over A. Now n is the power and we're trying to make n the subject. So what we can do from here is that we can introduce logarithms. So if we introduce logarithm to both sides, it can help us with that n. So log R raised to the power n equal to log, all we have here is A minus S plus SR all over A. Yeah. Now, if you remember the law of logarithm, it allows us to bring n this way. So n log R equal to log A minus S plus SR all over A. And we can divide both sides by log R. So if we do this over log R all over log R, this cancels this, then n equals to log A minus S plus SR all over A over log R. And that's n. So we've successfully made n the subject of this formula. Yeah, so if you like this solution, like the video and subscribe to the channel to keep getting interesting solutions to mathematical problems. I remain Earl Samm.